Wow, Algebra 3 class, this is it as far as new lessons for the year. We're going to have some review time coming up, but this is it. So, how about we start off today's last new lesson of the year with a joke, a really funny one. So, you ready? Okay, here we go. Why do you never see elephants hiding in trees? Because they're so good at it. Okay, so now let that sink in a little bit, and we're ready to go with your algebra. And I sure do miss you guys, because then I could actually see the eyes rolling back in the head. And I hope that you have a really great, blessed day. And I hope that this lesson sinks in and doesn't take too much of your time. Monday, obviously, you have off for Memorial Day. Tuesday is a work day on the assignment that goes with this lesson. So watch this lesson really well and then move right along into your weekend plans. And then on Wednesday of next week, you'll have a review for your quiz day. So I'll put up a review and you'll get to watch and listen and prepare for that. And then Thursday and Friday, you'll take your quiz on sections 9.1 to 9.4. We'll be done with chapter 9 at that point, and then transition into our end of year final exam review type things. So that's where we stand on that. And so here we go. So formulas and applications. Now, further applications meaning applications of the quadratic formula. So we will be getting into quadratics pretty soon. If you remember, though, we did earlier in the year where you had to solve for a specific variable, so we need to get back to that just a little bit and review that and then apply a quadratics to it and do a few little problems, and then we're done. So once again, if you're going to solve for a specific variable, you have to get that variable by itself. Inconveniently, our variable's in the denominator, but we can move that up easily enough by multiplying both sides by v squared. So don't forget that little trick, is that you want everything, all the variables you're solving, to be in numerator level before you do that, or you won't be able to solve. So then in order to work on it, we're still trying to get v by itself, so we need to divide both sides by w. And then in order to undo a square, you know that you have to take a square root, but it gives you two answers when you square root. So you have a plus or minus of the square root of this whole thing. But what that gives us is a situation where you've got a radical in the denominator, which we can't have. So we need to handle that. So you know that in order to handle that square root of w, you have to multiply by square root w over square root w, which will give you just a w in the denominator, and then all of these things in the numerator. So follow one step. You're always doing just one step at a time in algebra, you know that. So you do one step at a time. What do I know to do next? What do I know to do next? I need to check for radicals in my denominator, and go on from there. So you got this. Okay, looking at another one. So far we haven't gotten to quadratics yet. That's okay, because it's always good to be able to solve for a variable. We do have a square root in this one. In order to undo a square root, you need to square both sides. Then we need to get a by itself. So to get a by itself, I have to multiply by pi, and I need to divide by 4 on both sides. So there's our multiply both sides by pi. And then I can divide by 4. And I have my a all by itself. Just that quick. So you're probably wondering, well, so far we haven't used quadratics. Well, here it comes. So here we have a more difficult problem that says we're supposed to solve this for t. It looks like a quadratic because you've got a t squared and you've got a t, but you've got other variables in instead of numbers. But you can still use the quadratic formula in that. Okay, so we're trying to solve this for t. But instead of strictly having numbers in these spots, we've got some variables. A is 2, B is k, and c is negative s. So you still want to use your quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. But, like I said, you've got variables. So negative b becomes negative k plus or minus the square root of k squared minus 4 times 2 times negative s all over 2 times 2. And that's just them all plugged in. And then you want to simplify. So k squared is still k squared. 4 times 2 is 8, but a negative times a negative is a positive. 2 times 2 is 4. And it's solved for without having to do too terribly much with that. So we have a couple of word problems to deal with in order to solve and using quadratic. Sometimes you can use a quadratic formula and sometimes not. So these next few are going to be where you actually get an answer to a problem and then you're able to express that answer. So let's take a look here. 2 cars left an intersection at the same time. So we've got a picture, a mental picture in your mind. Sometimes it helps to draw a physical picture, which is what's coming next. One's going north and the other's going west. At some time later, we don't know when it is, they're 100 miles apart. The car going north had gone 20 miles further than the car going west. So we have a situation where the one going this way went 20 miles more than the one going this way, and they end up 100 miles apart. So we're going to draw it so you can see it. This is how far the car going west went. The car going north went 20 miles further than that, so W plus 20. This way and this way makes a right angle, so we have conveniently a nice right triangle and 100 here. So don't forget fun things like the Pythagorean Theorem. A squared plus b squared equals c squared. A squared, b squared, c squared. Now we're supposed to solve for w, so we have to do some work here. You've got to go ahead and square w plus 20. You might want to do that out on the side, maybe not. Maybe you're good at binomial squared by now, but w times w is w squared. 20w gives you 40w and 400 here. 100 squared gives you 10,000. Put your like terms together. We have this nice, wonderful quadratic coming out, and subtract your 10,000 from both sides, and you end up with a quadratic. You can divide both sides by 2 to get a coefficient of 1 here, and that's helpful. Because the smaller your numbers, the easier it's going to be, even if you do use a quadratic formula in this. You can either use quadratic formula at this point, or you can use factoring, if factoring will work. Here factoring does work. If I use 60 and 80, I get 4,800. And so when you have the 4,800 and I factor it, I get the 80 and the 60 that work in there. If you use quadratic formula, that's fine. It's just going to be probably more work. So if you can see something that factors easily, do that. So w minus 60 equals 0, or w plus 80 equals 0, which gives you 2 possibilities. Either the car that was going west went 60 miles, or the car going west went negative 80 miles. But think for a minute, negative 80 miles doesn't make any sense when we're talking about a distance. Now, those of you who are in physics right now know that we can have a negative, not for a distance, but we can have a negative for a position. But we're not talking about that. We're talking about just how far. And how far, we're only talking about the positive numbers. So 60 is how far the car going west went. And this one going 20 further than that went 80. Okay, so our final answer is that the car going west went 60 miles and the car going north went 80 miles because 60 plus 20 is 80. And if you check that in Pythagorean Theorem, 60 squared plus 80 squared does equal 100 squared in that. And it just works out like that. So quadratic formulas, quadratic equations can come up in word problems. I don't think this one's too bad. We have just 2 more to deal with. This one deals with, you've got a reflecting pool. You've got, which is those decorative pools. They just, the light reflects off of them. They're real pretty. But it's just this reflective pool that's 20 feet wide and 30 feet long, so it's a good size one. And you want to plant grass all around the reflecting pool. Okay, so make it really nice and pretty. And so you have enough grass seed to cover 336 square feet. And rather than have yourself in a situation where you start making the path too wide, you want to make sure that you're going to have enough seed to cover all of it once you started. So you're going to calculate how wide the strip around the reflecting pool is going to be. So we're going to draw that out. You have the reflecting pool. You don't put grass seed in the reflecting pool. You just put it on the strip around the reflecting pool. We know that the pool is 20 by 30, and we don't know how wide that strip is going to be. So here's our picture that we can use. 20 by 30 is our reflecting pool. The strip around it is W all the way around. So this dimension of this outside rectangle is 20 plus 2W. This one's 30 plus 2W. And so we have these 2 dimensions here as far as how wide and how long the strip will be. But what you have to keep in mind, though, is that this part doesn't get the grass seed. So when you're setting up the problem, you're taking the outer area for this whole entire rectangle, but you're subtracting out this inner area that doesn't get the grass seed. So your equation looks like 20 plus 2W times 30 plus 2W minus 20 times 30. And that'll give you the area that should equal 336, the amount of the seed. So here's our 20 plus 2W and our 30 plus 2W multiplied together. Subtract out your 20 times 30. That equals your 336 for your seed. So we then multiply it out, distributing twice. 600, 40W, 60W, and then finally 4W squared minus 600 equals 336. You then would put your like terms together to make it work out nicely. We put our like terms together. We can move over the 336 because subtracting 336 from both sides gives us a 0, so that puts it in quadratic form. Much easier if you make a 1 here, so if we divide everything by 4, they are all divisible by 4. It doesn't work out if they're not all divisible by this first term, but if they're all divisible by this first coefficient, go ahead and divide both sides by that. Everything divides out. We try factoring, and factoring in this case 28 and negative 3 gives you 84, and you can separate this out. This one equals 0 or this one equals 0. So you've got W equals negative 28. That makes no sense, okay, because you can't have a negative 28 width for a strip, but you can have a 3. So your strip of grass that's going to go around the outside is going to be 3 feet. So you would measure out 3 feet all the way, till it up turn over the dirt so that you've got a nice place around here, and then put down your nice good grass seed that's going to give you what you need. Okay, one more. All right, now in terms of if we're dealing with feet, this is the formula for how high something is going to be above the ground in a given time if it's projected upward from the top of a 144-foot building at 112 feet per second. You're not being asked to find this formula. If there's a problem like this, the formula would be given. Notice that it's quadratic form, t squared t, and then a constant term. We want to know when does it hit the ground. So you want to consider the height. Okay, this is the height. So if we think about that, what height is this object when it hits the ground? When we really think about that, that's at 0. Okay, 0 feet is the ground. So you can plug a 0 right into this formula. And once I plug a 0 in, if I divide everything by -16, I'm going to have a very nice thing to deal with. This is not factorable because 9 and 1 doesn't give you 8, and neither does 3 and 3. So what you need to do is we need to resort to quadratic formula for this. A is 1, B is -7, and C is -9. If you didn't think of doing dividing by -16, you could use 16 and -112 and -144, but that's a lot more work. So 1, -7, and 9. Negative b plus or minus square root b squared minus 4ac. Watch out for this negative. It still gets some people. Okay, I've noticed that. -7 times -7 is positive 49. I think some of you try to rely on your calculators so much that you forget to put parentheses in and you don't feel like showing steps. Just some of you. Even if you're using calculators, you're much safer if you show your steps. Okay, so for example, here, rather than just trying to put this all in all at once, go ahead and put in your steps. This is 49. It should jump out in you. When you've got a negative times a negative, you get a positive. I think a lot of times people make mistakes and there's a negative that sneaks in here, even if you don't mean it to be. Even if you would have seen it and known that it was supposed to be positive, a lot of times people will forget to put parentheses around when they're doing the problem with the calculator, and then because of the way it works and the square root is incorporated too many steps lead to all kinds of mistakes. So be careful. Here, negative times negative also gives you positive. And then 85, square root 7 plus square root of 85, or 7 minus square root of 85. This is where you could use your calculator to get about 9.2. And so once you've got that 9.2, 7 plus 9.2, 16.2 divided by 2, which is 8.1, or 7 minus 9.2, which would give you negative 2.2 over 2, which is negative 1.1. So think about this. These are time numbers. Does it make more sense to have a positive 8.1 time or a negative 1.1 time? Since you can't go backwards in time, your positive number is the one that actually makes sense. These word problems, you always want to make sure that your answer makes sense. All right, that's it. Last new lesson of the year. Then we're working on getting you ready for your final. I will get those materials out to you fairly shortly. The answer key's already up there, but the questions aren't. So I need to get you the questions, which I will do so that you can begin to study and be ready for that. But your first hurdle that you're working on will be that quiz that I talked about earlier. And Monday is a work day. Monday is your Memorial Day. Happy Memorial Day. Tuesday is your work day for 76. Wednesday is your review for your quiz. Thursday and Friday are your quiz, which I'm imagining actually meant many of you might want to just get it out of your road on Thursday and then take a rest on Friday. And then that's it except for the final. And we'll be working on the final exam review the following week. Your final exam will be given on Monday, June 8th, as will all of the odd period finals. So just get your head around that for all of your classes. That's it. I miss you all, and I wish you the very best. Have a great Memorial Day, and God bless you.